Good afternoon, friends. Welcome to this press conference on BioNext Tech Innovations. To brief you on more on this subject, today we have with us Honorable Minister for Science and Technology, Dr. Jitendra Singh ji. My warm welcome to sir. I am happy to welcome Secretary DPT, Dr. Rajesh Gokhale ji, Dr. Alka Sharma ji, Director DPT, Dr. Debashish Mohanty ji, Scientist DBT, Dr. Jyoti Lagani, Scientist DBT, Dr. Parveen Vamula. The format of today's press conference will be like this. First, there will be a presentation on new initiatives on improving tuberculosis outcome by Dr. Jyoti Lagani and Dr. Mohanty ji. After that, Honorable Minister will launch of commencement of pilot phase of Indian Tuberculosis Genome Sequencing Consortium and Novel Technology and Product Development and DBT. After that, there will be presentation on the novel blood bag technology to enhance quality and shelf life of stored blood. After that, there will be the address by Honorable Minister, and then we will take few questions and answers. There will be session, and then thank you. And over to Dr. Jyoti Lagani and Dr. Mohanty ji.
Thank you, sir. So I extend my greetings on behalf of the Department of Biotechnology to the dignitaries on the dais and all the colleagues from DBT, BIRAC, and the eminent scientists who have joined us today. So we would be basically the government of India has placed a high priority for TB Mukt Bharat, and in alignment to our Prime Minister's vision, we all need to participate. He's looking forward to the participation of everyone to strengthen the efforts to secure a future, and he has a vision for a TB-free society. So considering the same, the department is planning to take two major initiatives on improving the tuberculosis research outcomes. The first focuses on the deployment of Ayush interventions to improve quality of life of the TB patients, and the second focuses on establishment of an Indian Tuberculosis Genomic Surveillance Consortium. So on the first effort, we will be doing collaborative efforts will be taken along with the Ministry of Ayush, and we aim to conduct high impact research studies on deployment of the Ayush interventions as an adjuvant to the anti-TB treatment. So this model would be a collaborative model between the DBT research labs and the premier hospital institutions. So considering that there are considerable challenges as an outcome of the current TB treatment, whereby the people undergoing treatment suffer from various side effects, including cachexia, that is severe muscle wasting, hepatotoxicity, impairment of lung function, which affects overall the quality of life, which is caused by the TB medications. And these complications lead to either discontinuation or even prolonged treatment. So considering that fact that Ayurveda has a unique concept of rasayan to promote vigor and vitality, providing nutrition and supporting immune system, we aim to explore the potential leads which have been developed from Ayush, which may have promising outcomes on the TB treatment and management. So some of the promising leads such as Amla, Guduchi, Ashwagandha from the literature have shown role in the symptomatic management of the TB, symptomatic management and improvement in the loss of body weight, respiratory systems, and also increasing the bioavailability of the treatment drugs. It also plays a role in hepatoprotection and improving the quality of life. However, there is a lacunae for well-planned, high-impact, multi-center studies, such as both clinical and preclinical. So considering there is an umbrella MOU which has been executed between the Ministry of Ayush and the Department of Biotechnology, which focuses on developing evidence-based biotechnological interventions. We aim to evaluate the effect of modified anti-TB treatment with inclusion of the Ayush intervention versus the conventional treatment. And it is envisaged that this will fill the knowledge gaps regarding the application of the Indian system of medicine and will have an impact in improving the lung and the muscular health and thereby ensuring optimum quality. The other initiative which was launched last year by the Honorable Minister, which our Honorable Manturiji, that is we call as the data-driven research to eradicate TB, which was announced on the last World TB Day, focuses on 4 major components, and the one key component is the setting up of the Indian Tuberculosis Genomic Surveillance Consortium. The other activities include setting up of a knowledge hub, whereby we have launched a webinar series, and department has also taken efforts in developing the proposals to address host-directed therapies as well as evidence-based regimen for treating extrapulmonary tuberculosis. So under this umbrella, the key component is the Indian Tuberculosis Genomic Consortium. This is an activity which is being driven. This is an interministerial effort which brings together the labs from the Department of Biotechnology, CSIR, ICMR, and it is proposed on the lines of INSACOG, which created a very strong surveillance network for COVID-19. So we target to sequence around 32,200 TB samples, TB strains which are prevalent in India from a pan-India representation. So this would provide us information on the prevalence of the strains, their drug-resistant patterns, and their association with the treatment outcomes. So the data would be very helpful in identifying the different TB lineages, and patterns of transmission would help in further in planning of the public health measures that can be undertaken. So with this, I would hand over to Dr. Mohanty to talk further about this effort.
Thank you, Dr. Jyoti, and Honorable Minister Dr. Jitendra Singh ji, Dr. Gokhale, Secretary DBT, and all other dignitaries on the stage. As Dr. Jyoti has already told about INTGS, so this project has several unique components. Before we actually start the project, this is a pilot phase just to test that we can really do it to the scale and to complete it in the desired time frame. So this is another thing is it is bringing many other institutes together, both from the DBT setup, ICMR setup, as well as Health Ministry. So, and it links clinic to the genomics and even data analysis and machine learning. So the sample collection will be there on from the report sites of JIPMER, and even ICMR is also covering through NIRT and PD Hinjura Hospital. And there will be a sample repository at ICGEB, so all the TB strains will be maintained as a repository, and after DNA extraction, they will be sent to CCMB and like CSIR CCMB and DBT NIBMG for the genome sequencing. And this one, and there will be some even if required detailed MIC calculation will be done by NIC and Hinduja. And the most important thing is, as you said, and the Dare to ERAD has a knowledge-based approach, we have to really make use of the machine learning, which is being increasingly used in biology. So a major part of the data analysis is not only assembling the genome, how can we map the mutations, link it to resistance, and currently for a diagnosis of the resistance TB, you go through a DST or a antibiotic sensitivity test, which takes several weeks. But once with this data, we establish like genotypic prediction is actually mapping with the phenotypic prediction, you would be one day with the advance of machine learning, you will be able to do this diagnosis based on genome sequencing directly in the clinic. And things are improving. Your sequencing can be done with nanopore and handheld device. That is the overall objective. So in the pilot phase, what we had done is we had taken 182 samples, and this came from all the places, and they reached on 10th of March in this one, ICGB. By 13th, all the DNA extraction was completed, and the samples went to the CCMB. Within a week, the sequencing, all the raw reads came to NII, and within 2 days, we completed all the assembly and analysis, and this database has been available public, and that is Honorable Minister will announce this pilot phase. And currently, that 182 sample have been sequenced, and this is the genotypic resistance profile which is predicted. There are so many antibiotics, like out of this one, almost out of 182, like 50 plus are showing the resistance to different genomes, and this one, and there are many which are resistant to multiple antibiotic, like as you can see the last one, though it is one sample, it is almost resistant to everything, and that is the major thing. And what we plan to do is in future is how to use machine learning more effectively. Currently there are machine learning models, but they are all based on the data from abroad. So with this project, as we reach 30,000, as Dr. Jyoti said, we will be able to develop these machine learning models using the data which we generate in India based on TB sample sequences. So we can have better predictors, genotypic predictors, and probably the overall goal can be achieved. So I would, I would now leave. This is the logo of the NTGS, this one. So I would stop here. And
so I request Honorable Minister to launch the commencement of the pilot phase of the consortium by push of buttons up. Now I request Dr. Parveen for presentation on novel blood bag technology to enhance quality and shelf life of stored blood. Dr. Parveen.
Good afternoon. Honorable Minister Dr. Jitendra Singh ji and Secretary DBT Dr. Rajesh Gokhale ji and all my colleagues at DBT and the delegates. And today I quickly summarize one of the new technology that we developed, that is novel blood bag technology to enhance the quality and shelf life of stored blood. And as you know, like transfusion of healthy blood is a life-saving practice, and millions of people get transfused every year. And typically in India, 12 million units of the blood required annually, and we get more than 10 million units of the blood through donations. But despite of this scarcity, more than 1 million units, that is almost 5 lakhs liters of the blood discarded due to the decrease of the quality during the storage. That's why huge unmet need to develop the technologies to improve the quality of stored blood. And typically, according to the protocols, one can store the maximum allowed time for the storage of the blood is 42 days. But technically, up to 21 days of the stored blood is safe to transfuse, because after that the quality is declines. And therefore, it is important to increase the quality during this storage time. And while storing the blood, there are cells die and they generate this compounds called damage-associated molecular patterns, and these are including a DNA, nucleosomes, and proteins, and so on. And these are the dams go and attack the stored blood cells and they damage their quality. So, and when you have these dams containing blood, if you transfuse to the patients, and that also leads to the severe clinical complications, including internal damage and damage of the organs and so on. And that's why the various scientists across the world from last 2 decades have been trying to develop the technologies. And so far, people have focused on developing various storage solutions and the preservative solutions to protect the stress from the for these storage cells. But this doesn't address actually problem causing dams, because so far no attempts have been made to remove these damage causing agents from the blood. That's why we thought of developing technologies to remove them. If you see all these molecules, these are a charged component, either they are positive charge or negative charge. That's why we systematically develop these polymer molecules which having the complementary charges, which can be formulated into nanofibrous shield, which can develop as a new blood bags. And when you have these new blood bags, you can store this blood here, and even by treating 15 minutes from these blood bags, it can capture very efficiently all the charged molecules and release the only healthy cells. So due to that, we could able to show that we can increase the quality of shelf life significantly. Just to summarize that, when you have this dams associated whole stored blood, if you transfuse them, that can lead to immune system activation and further internal organ damage and so on. But what we have shown is when you have treat with this new blood bags just before the transfusion or during the storage, we can completely prevent this immune system activation on all the transfusion related complications. So to summarize the key factors from these technologies, it is shown to be a very safe and robust and scalable technology. And this technology selectively removes only damage-causing agents without damaging any stored RBCs and the blood cells. And also we have shown that By using these new blood bags, the old storage blood quality is as good as freshly collected blood. And also we could able to increase the shelf life of the stored blood more than 25%. And this is highly validated using robust preclinical animal models, and it's a highly patent protected technology. And recently we also shown that this technology not only increase the quality of stored blood, but it also can increase the quality of stem cells as well. So after developing this technology to further commercialize this technology from InStem, we formed the spin-off company which is developing further to commercialize this technology. With that, I would like to stop, and I would like to thank all the DBT and the InStem for generous funding which enabled us to develop this technology. Thank you all.
Now I request Honorable Minister to launch this novel technology by push of button. So now I request Honorable Minister to address the gathering. Oh, yeah, please.
Honorable Minister for State, Science and Technology, Dr. Jitendra Singh ji, others, dignitaries on the dais, Dr. Mohanty, Dr. Alka Sharma, Dr. Jyoti Lagwani, Dr. Praveen, and all the dignitaries of the dais. It's my real pleasure to have you, all of you here on very, very important occasion actually. So the two activities that we have showcased are very important areas of one for TB, which has been a major scourge in India for several decades now. And it's been a problem that government has been very, very highly focused on. And you must have recently seen Honorable Prime Minister also taking very important steps towards directions recently that he announced in Banaras. What Department of Biotechnology is also doing is enhancing the capacity and capability of how we will be able to identify drug resistance organisms in the clinics actually. And the classical method that is used is using microbiology based methods actually, which takes about 3 weeks time for you to identify whether you have a drug resistance bug and how to be able to identify it and how will you be able to treat them differently. This technology using genomics based method and combination of artificial intelligence and machine learning languages, this will allow you to actually identify this within 2 to 3 days. And this will therefore enhance the quality of life of individuals as we can very quickly start them on these drug resistance aspect, taking care of it. The second aspect that we have talked about is of Ayush, combining Ayush trials with this. You know, what is typically happening is that the lung infection in TB as it happens, one needs to recover the good quality of lungs so that your next future life is very hale and hearty. And therefore, Indian systems of medicine, in fact, have many of these important rasayanas that have been developed, which is useful to be able to clinically test and validate. And that is what we are going to do and identify and carry out this further. Finally, this wonderful technology that has been developed for storing blood for long period of time and also enhancing the quality of the blood. Because blood, as you know, is the real life, is very, very critical in human life and frontiers actually. And I think this technology has already been now filed for a patent. And in fact, he has a startup company that is actually going to take this POC studies to the future of the work. So I'm really grateful Honorable Minister took time, and under his guidance and leadership, we are doing this innovative solutions for healthcare towards people's lives and careers. And I hope we will make big impacts in future to come actually. And I think these, in another 6 to 8 months time, both of these technologies should move into the utility value and the societal values actually. Thank you very much, sir, for taking your time and coming over here and giving us your time. Thank you.
I request Honorable Minister to address the gathering. Thank you.
Thank you. I don't know how many of you have realized that what also makes this afternoon of 27th a little special is that I am surrounded by two Rajeshes, both of them having made a mark on themselves. So I have to also use this opportunity to congratulate Rajesh Malhotra for his new assignment, and I'm glad that he's there with us. And of course, Rajesh Gokhale, besides being secretary, an eminent scientist in his own right. Now, when we look at this, I think it's in the three parts that we could actually understand it. The journey of tuberculosis management and prevention globally, also in the tropical countries. B, its relevance and our goals in the context of India or the Indian subcontinent. And C, the prioritization on the part of the government headed by Prime Minister Modi. So if you see the tuberculosis as such, we have had a very miraculous journey, which is actually, I think, also is timed with the journey of the management and therapeutic advances across the world. So beginning from times where we hardly had any drugs at our disposal, and most of the management and most of the diseases was happening through non-pharmacological methods, and therefore we had huge big sanatoria or sanatorium, and they would be built into acres of land with greenery all around, so that the treatment was allow the patient to have fresh air, and his mattresses would be kept in the sunlight so that they would get de-sterilized. So all those methods. And then, God forbid, if he got one of those complications which Rajesh was referring to, if he got fibrosis in the course of disease or the lung went off, then maybe he could also meet a mortality, and the consequences would not be so. In 1950s, early 50s, we got streptomycin, which is known as the first line of drug. And then, of course, the second line, rifampicin and pyrazimide and all these things. And almost we had been able to get over this malaise of infectious disease. But then suddenly, I think the setback happened with the advent of HIV and other things. And at least in the West, nobody knew about all these diseases. In fact, many of their researchers came over to India. Though the tuberculosis bacteria had been discovered by a Westerner, Robert Cox, but the research was mostly done by their researchers in India because the patient material was available here. The bacteria was operating more in these countries. But, and unless HIV happened, and then they also started experiencing. I think gradually we got over that phase. We gradually moved on to the communicable, from the communicable to the non-communicable diseases like metabolic disorders, cardiac diseases, diabetes mellitus, etc. But suddenly the setback happened, partly with HIV and partly with the COVID now. So, and for India, the special challenge, the second part I'm saying from the context of India, that India was always known to be the hub of the tropical diseases and the infectious diseases. In fact, when we didn't have much of the prevalence of these more sophisticated diseases, like the lifestyle disorders like the coronary disease, etc. So when we started happening, some of the Westerner commentators said that India has now started acquiring diseases of the civilized. So they were known as the diseases of civilized because these were the diseases of which actually emanated out of lack of hygiene or too much of population. So now having got back into this, again I think the onus to a great extent and also an opportunity to a great extent lies with India to prepare the regimens and to make the way forward for the rest of the world to follow. And to that extent, we have to thank Honorable Prime Minister. TB eradication goals laid down the world over are 2030. He has set for us the goal of 2025. And I'm sure we would be able to show the way as we've done in the vaccine story, which also emanated from the same department. Also because Prime Minister himself has been giving a high priority to health care, particularly after COVID, a lot of emphasis on preventive health care. And in his Varanasi speech the other day, he was referring to an incident when in Ahmedabad, Mahatma Gandhi came to inaugurate the leprosy hospital, and he said, I'm waiting for the day when this hospital would be locked. And it did get locked in 2007 when Mr. Modi was the Chief Minister. So I think the ideal goal would be when we don't need to have tuberculosis hospitals. Like, for example, many of the sanatoriums have now been closed down. Almost 70% of the sanatoriums which existed in 1940s are now closed down. Incidentally, I had my internship in one of the best institutes in Asia, the Tamram Sanatorium, which is said to be. But now, since we have this new armamentarium of drugs, so I'm sure with the new regimens, and also now the importance of the program which was being mentioned and which was launched just now, the program called INTGS, Indian Tuberculosis Genome Surveillance. So we are now also graduating to more sophisticated methodology. Earlier it was mostly microbiology based, now we'll have more specificity, also saving of time, and we would be able to achieve the goals in a shorter span of time. The other program, which is also driven from the same department, is the data-driven research to eradicate tuberculosis. And then, of course, the other part, as Rajesh was mentioning, our MOU with Ayush. The program is going to be launched formally and jointly by the two ministries, the two departments. I think now that we are into a phase of integrated, holistic healthcare, and the lesson has been taught most seriously and forcefully than by COVID than none else. Earlier on, there used to be some skepticism among different systems of medicine. Particularly the allopathic medicine didn't think much about the indigenous medicine. But you saw in COVID, everybody was looking for booster drugs or immunity boosters among the Indian origin, if at all possible. So certainly in drugs like tuberculosis, or in the disorders like tuberculosis, where building of immunity and particularly building of the lung capacities has a great part and a great role in shortening the course of treatment. And therein come the traditional Indian methods, the yoga asanas, which train you for deep breathing, long breathing, lung expansion, etc. So I'm sure by combining all the three, we will be setting up a new course of regimen for the rest of the world also, because they may not be so much familiar with that. And finally, the blood part, of course, which was now the new technology, back technology, and many a time, I think this also goes hand in hand, because nowadays in the age of sophistication, the commonest causes of anemia in the middle class are kidney failures, because the hemoglobin generation reduces. But in diseases like tuberculosis, it's because of the lack of nutrition, because there's loss of appetite. In one of the slides I was noticing, you mentioned cachexia, which is nothing but loss of appetite, and it becomes all bone and flesh. And therein again, blood transfusion has a role. So I'm glad that both the technologies are being launched together. They will supplement each other, superimpose each other, and at the same time, also aligning them or synergizing them with Ayurveda, Yoga, and other methods. So we are going to set a roadway or a headway for the others as well to follow. I congratulate Rajesh Gokhale and his team, and we look forward to have a joint launching with the Ayush Ministry very soon. Thank you, Mr. Malhotra.
Thank you, Ji. Thank you, sir. I request the media persons to ask the question, raise the number plate so that I can call them. 100.
My name is Rekha Dikshit, and this is my question to Mr. Praveen Vimula. You mentioned this new technology for enhancing the life of blood. What exactly is this? Do you have some molecules inside that do the job, or can you just give us a little more details?
Yeah, so this bag is made up with the polymers, and these polymers have a charged components. So all the damage causing agents which produced by blood cells during the storage, so this bag captures them so that like they will not go and attack other blood cells to damage them. So that's how it's selectively removing these damage causing agents. That's how it prevents all the further damage and increase the quality. No, it's not filtration based. It's like you can just incubate on them. What it does, it captures only the damage causing agent, but it doesn't, hold any or attach any cells on it. Because when you filter it, like we might lose the cell count we loses. So in this case, like we don't see any cell loss at all. So that's why like we avoided the filtration technology, it's just the incubation technology. Yeah.
Sagar.
I mean, can the blood, 42-day-old blood be used for transfusion, or is the blood life increased further?
Yeah, so with right now with our data, what's suggesting is like even 42 days stored blood, the quality of that by using this technology is as good as freshly collected blood. So because we are removing all the damage causing agents, so it is as good as fresh blood. And in addition that, like the shelf life also from 42 days, it can be increased to 51 days now, 25% more we can increase.
Next, Roshan.
I think what Rekha was trying to ask here, and glad that you made it clear. It's not that they are adding any ingredients into the blood, which he meant. It's just that it's preservation through storage, improvement in the storage method.
That's absolutely right.
रोशन.
सर मेरा सवाल है कि जो ये आपने सिस्टम शुरू किया है उसमें जो ब्लड ट्रांसफ्यूजन का रिस्क फैक्टर है वो कितना कम हुआ है, क्योंकि अभी भी ऐसी खबरें आती हैं कि ट्रांसफ्यूजन से और जो तमाम बीमारियां हैं वो फैल जाती हैं.
Yeah, so when we have the old stored blood transfuse, when you transfuse them, and it causes your entire immune system gets activated. So that leads to internal organ damage and all, especially like, patients if already have other comorbidities, if they are suffering immunocompromised patients and all. So with this one, like with this technology, like since we are removing entire this damage causing agents, and only red blood cells only will be get transfused. Because of that, we can avoid all the systemic inflammation, systemic immune system activation complication, completely prevented. Yeah.
Yeah.
Yeah, Dr. Gokhale, Dr. Mohanty, can you please explain how does this TB genome sequencing project will help clinically? Not every patient's blood will be checked through this. Like, so how does it help a doctor treating the patient?
Yeah, sorry. So see, when there is a, let us say, resistance to isoniazid, there are mutations in CAT-G genome. Like in the CAT-G gene, there are mutations. And with a lot of data, if this is established, and there are many other mutations, if we can establish that this is a genomic signature of resistance to this drug, you do not have to wait to do a microbiology-based test to conclude. It can be.
I think one of the biggest challenges here is what is known as the multi-drug resistant tuberculosis, MDR. So there comes a stage in case of certain patients, all the options fail. So if you are able to detect at an early stage what precisely is the mutated form which is affecting, and you are able to actually address it in the early stage, you might be able to get better results and better prognosis. So that is the improvement.
Yeah.
You want to add?
So I think, so for example, अभी इंसाकॉक की जैसे एक्टिविटीज़ हैं, आप लोग कोविड वेरिएंट्स की बात करते रहते हैं एक्चुअली कि स्पाइक म्यूटेशंस हैं और ये हैं. इसी तरह से यू कैन आइडेंटिफाई बिकॉज द जीनोम सीक्वेंस ऑफ माइकोबैक्टीरियम ट्यूबरकुलोसिस इज 4 MB, 4 मेगा बेस एक्चुअली, और जो कोविड का जो है 30 KB जीनोम सीक्वेंस है उसका एक्चुअली. सो टीबी जीनोम में बहुत सारे नए म्यूटेशंस एक्यूमुलेट हो जाते हैं, and these mutations then are attributed to antibiotic resistance. और अभी जो normally microbiology methods use करते हैं तो 4 main drugs के against ही microbiologically test करते हैं, but अभी TB के लिए total of 14 drugs available हैं, and therefore one can genome sequence करने से आप identify कर पाएंगे कि कौन से variants हैं और किसके mutations available हैं. और इस म्यूटेशन से तो आप वो ड्रग का इस्तेमाल मत करिएगा, दूसरे ड्रग्स दीजिएगा. So this is why the technology what you will use is he will be prompted by saying that he will send the sample for genome sequencing, and then the genome sequencing data will immediately tell you what is the outcome of it actually.
नहीं, ये सभी लैब्स में आ जाता है फिर बाद में। जैसे अभी जो ये कह रहे हैं, पहले क्या करते हैं, ड्रग सेंसिटिविटी टेस्ट करते हो, डिस्क के ऊपर लगा के देखना। इसमें जीनोम सीक्वेंसिंग मच मोर स्पेसिफिक, मच मोर सोफिस्टिकेटेड एंड covers a wider range of drugs, isn't it?
So obviously path labs, I mean path lab की जरूरत नहीं पड़ेगी, जैसे genome sequencing जैसा अभी चल रहा है। So normally maybe you want to add?
Actually, there is a change in the sequencing technology also. Like currently, if you are using short read Illumina, you have to use more expensive devices. But there are long read sequencing with nanopore and all. So these are almost like handheld devices. With that, a sequencing can be done much easier, even directly at the clinic. But of course, it requires certain developments. And one more development which has to come is, can you directly take DNA from the sputum and sequence without culturing the bacteria? So all these things, when this is going in that direction. So that is where the time will be shortened very dramatically. Like you don't even need to culture the bacteria.
More specific also.
Yeah.
Even your DNA is a better substitute to that conventional sputum.
Yeah.
Because sputum sometimes people will spit out and it will be negative, because it doesn't come from underneath. So,
any other question? Yeah, please.
I'm Rohini from Down to Earth. So I wanted to understand if you'd be using the sequencing data to design new drugs or vaccines or anything like that.
Yeah, it can in principle be used, like if you understand on which gene the mutation is happening, or is it happening in a flux pump, or it is happening in some non-coding region, potentially it can help you to understand actually what is the molecular basis of drug resistance. And using that, there are publications, these are not clinic examples, people have able to design resistance breaking compounds. That bacteria was resistant to a particular drug. They figured out where is the mutation. This work has been published in Science also. They could design a molecule, then that same bacteria was now susceptible to this new molecule. So, but that would require other laboratory experiments and other details, and all these data will be available to people, and even the laboratories who are engaged in genomics, molecular biology work or TB research, they will be able to use this data. It can be also better correlated with the clinical information. So like the final website that which Honorable Minister inaugurated, that portal, it is also going to have clinical details of the samples, like all that. So that is where it will definitely help in this thing.
So do you have a timeline on how you're going to scale it up and all that?
So the timeline is what is proposed is for this 30,000, it is proposed like within 2 years, but what we estimated from the pilot phase, we should be able to do it in 1 year also. We can do now with the current, even this with these 2 institutes what we standardized, and of course currently we did the manual extraction of DNA, we are getting automated extraction. With that, you would be able to easily do 500 this thing sequences per week, and this we can scale it down to this one. This is one is CCMB and NIBMG. Dr. Sagar Sen Gupta is the director, he is there, and CCMB is the other laboratory is doing sequencing. And NII would also, we have now long read based, nanopore based sequencer, but once we get we are also going to get the short read, we would also join in this project.
Any other question?
And actually we are mostly confining ourselves, because that happens instinctively, to pulmonary tuberculosis. But tuberculosis as such is an infection which can affect any other organ as well, except perhaps liver, maybe not. Your spleen, of course, doesn't get affected. We could have nodes. So extra pulmonary tuberculosis is also one part of it. And these new methodologies could be of utility there as well, because you may not have a person coughing around and still having tuberculosis somewhere. May not be having also those typical symptoms which you find in a lung tuberculosis. But these more sophisticated investigated methods would be there, relevant there also. So I think we are now evolving from one level to the other. Yes. You wanted to say something about these center, right?
I think the traditional methods are useful, but they are very time consuming actually. And therefore to give the right treatment to the patient, the duty responsibility is to give it at the earliest, so that, and that is what this whole genome sequencing program will do actually. Because this will within 2 days, you will get the data and you can start patient immediately on this activity. And abhi jo genome sequencing activity, what we are only doing in few labs. So as the quality of the data is very, very important when you generate the base actually. After this, once everything is done, we can actually work with various path laboratories and various laboratories who can generate the genome sequence and give it to the patient within hour. Already you must have heard that Reliance has already announced saying that they're going to start low, cheap cost genome sequencing services in the country actually. So many of these activities will fuel up the activity and will make sure that these become very, very important.
Actually, the genome sequencing is not only also limited to tuberculosis. It's one of the new methodologies in the armamentarium of our diagnosis and management. So it's like for example, traditionally, as he was saying, if you had to go by the other methods, or for example, the sputum test, it would not be positive at least for 3 weeks, maybe even later. So the 3 weeks are lost. Similarly, the X-ray shadow may not appear that early. And that is applicable to other diseases also, depending on the symptoms. The symptoms may not appear. Even, for example, in case of jaundice, the discoloration of the eyes may appear after 5-6 days. So these are some of the methods which give you an opportunity for early intervention. And they are applicable in different diseases now. Finally, I think the next step would be genetic intervention, gene intervention, wherever feasible.
सर सौरभ हिंदुस्तान अखबार से
राजेश wants to add.
और सर मेरा सवाल ये था कि
एक मिनट राजेश बोल रहे हैं कुछ.
जैसे अभी सर ने कहा वैसे I think what we will do is I think these genetic methods allows you to do the diagnostic part. But obviously intervention strategies can also be developed, and that is what in future we'll use them as a mechanism.
The stem cell and other things are also useful there.
First, Saurabh, then Madam Rekha.
तो सर मेरा सवाल था कि ये सिर्फ एक प्रिवेंटिव मेजर ही है या हमारे पास कोई ऐसा आंकड़ा भी है जिसमें हम ये कह सके कि नहीं इतने लोगों में रेजिस्टेंस हो गया था ड्रग का, इस वजह से हमें इस तरह की टेक्नोलॉजी की ज़रूरत पड़ रही है या आगे पड़ेगी, ऐसा कोई डेटा टीबी को लेकर के?
रेजिस्टेंस का डेटा तो टीबी का एनुअल रिपोर्ट में आपने देखा ही होगा, अगर नहीं देखा होगा तो हर साल टीबी का एनुअल रिपोर्ट पब्लिश करते हैं. एंड अभी तक जो इंसिडेंस रेट जो कहते हैं कि अभी 10% के करीब है इंडिया में एक्चुअली एमडीआर और एक्सडीआर रेजिस्टेंस. एंड ऑफ कोर्स यू नो दिस इज अ नंबर दैट ओनली जितना स्क्रीन करेंगे उतना ही आपको पता लगेगा एक्चुअली. बट 10 से 15% लोग अगर ट्रीटमेंट के बाहर हो तो इट्स अ बिग प्रॉब्लम, बिकॉज वो सब जगह घूम रहे होते हैं एंड यू कैन इन्फेक्ट मेनी मोर पीपल एक्चुअली. सो दैट इज वाई इट इज़ वेरी इंपॉर्टेंट टू ट्रीट अर्ली, ट्रीट फास्ट and very quickly make sure that the transmission is not there actually. So जैसे ही आप transmission cut कर देंगे वैसे ही आपको automatically you know the spread in the society will be much less.
10% अगर ऐसे हैं जो drug resistant, 10% ऐसे भी हैं जिनको बिना पता लगे ठीक भी हो जाता है. Yeah, no, that's true. If you do a mass screening and just nothing much, just do X-ray chest, you will find old healed shadows. So many. So easily, depending on the level of the immunity of the individual and the comorbidities. But these are the interventions which help you in picking up early.
Last question, Madam Rekha.
Mr. Vemula, your presentation went by very quickly, but we seem to have noticed that there is already some company which is some startup which has started commercializing this. Can you just explain that in
Not at the company we just formed from is a spin-off company from InStem. Now the technology will be transferred from institute to the company, so that like it can further.
You are yourself a startup.
That's right.
Okay. Oh, good that you picked up that I also didn't get.
It's a Capture Bio Private Limited.
Okay. That even I didn't realize.
Thank you, sir. Thank you, friends.